In this video, we will try to find an equation of a tangent line to the curve y equals to 1 over x, hyperbola, at the point 2, 1/2. In order to get a tangent line, in order actually to get an equation of any line, we will need slope. We have point, that means we remember the point slope form is quite helpful, but we need slope. Slope usually we calculate through delta y over delta x, meaning the difference in y is difference in x. And then we will need 2 points. And we can realize quite quickly that finding the slope between the point and itself, it will be a little bit weird because the x value is 2, the corresponding y value is 1/2 because it's the reciprocal. And then when I subtract 1/2 minus 1/2 to minus 2, like no rise, no run. That means this is, we can see that's not exactly the way that we will do it. But what we can do, we learn that the slope of the tangent line is a limiting value of the slopes of the secant line. I mean, I pick a couple of points on the right-hand side greater than 2, 2.5, 2.1, 2.01, 2.001. And then we will create that interval, smaller and smaller. The coordinate of the other point that we decided to choose to create a secant is getting closer to 2. We can see 2.5, 2.1, 2.01, 2.001. We may do exactly the same thing on the left-hand side. 1.5, a little bit far away, 1.9, 1.99, 1.999, and even closer. And then based on all of these values, especially the slope, we will try to approximate. Because we know that 0 over 0 is, I just put 0, but we know that it's not exactly 0. We're doing these limiting values, and that's just arbitrary small numbers. Tiny numbers, but not 0. And we will get a finite number. Okay, that's what we can do. Too many calculations, but let's maybe focus on some. And then we can use the calculator or probably the Excel spreadsheet to get all of these values. Okay, that's me. What I will do, I can possibly change the slide for a second, and we will draw this function 1 over x. It's hyperbola, and I hope everybody knows how this function looks like. Because we do have a couple of functions, I think around 9 graphs, quite common, quite fundamental, that we supposed to know the shape. I can end up this session with drawing all of these functions. Okay, first of all, we need this. Y and x, arrows in one direction, we remember, and function 1 over x looks like hyperbola in the first and the third quadrant. Okay, we just focusing at the point, let's use green, at the point 2, 1/2. Actually, I will use, because I use the calculator, that's mean I will say decimal 0.5. And we will need a tangent line. Okay, we're looking for the equation of the tangent line. Okay, but we know just 1 point. That means I will pick a value. I would like to make it clear, 2.5. This is my second point. And then it's the nice thing about this line, we have 2 points. The value for the reciprocal of 2.5, it will be 0.4. You may check using calculator. Okay, and the good thing is we can see nicely the rise and we can see nicely the run. All right, that's we see a rise one more time and a run, a little bit. Okay, and I can call it delta y and delta x. Right. So my first interval is between 2 and 2.5. This will be the slope. And of course, slope, yeah, this is my first one. Slope is the changes in y, changes in x, rise over run. And I can say, my new point, the y values first. Let's actually start with the x, but let's put 2.5 minus 2, and then the corresponding value for 2.5 is 0.4 minus 0.5. Okay, I mean, we will always have point like a half and 2. That's the point, yes, because this is the point of the tangency 2, and let me put 1/2. 1/2 is the same like 0.5. So we can see this will not change. We will just get closer and closer. Okay, and if we will need value, actually these values are not bad. 0.1, this one is actually 0.5, -1/5 will give us -0.2. I need a little bit, because I would like to keep everything nice and okay. 1/5 is 0.2, of course, negative. Okay, we have the first slope, the blue line. But now we know that we can make better. I mean, the second option, I can get a little bit closer, 2.1. And what I will do, I will just simply, I don't want to draw the line closer and closer. I mean, this will be just 2.1. And the reciprocal of 2.1, this will become 0.4762. Of course, I use the calculator. And now the same thing. Let me use that color. Okay, slope will be changes in y, changes in x, and now I will put 0.4762 minus half, yeah, still this one, and then 2.1 minus 2. And we will calculate the difference and everything, but what I can do, you can check the calculator, I will put the slope, negative 0.238. Okay, this one was -0.2. Okay, and maybe one more. Yeah, I will put these values. Let's put the third interval. We can get even closer, 2.01. And then when we take the reciprocal of 2.01, we will get 0.4975. Okay, and then this is the interval, 2.01. Okay, so we will calculate slope. Again, changes in y, changes in x. Now we have 0.4975, still minus half because it's that distance. And then the value of x is 2.01 minus 2. And when we use calculator, the slope is -0.02 and actually is 4.8, and I can put 7 also. Okay, and then you can see that's the process. That's what we have to do. We have to find the corresponding, for the corresponding x, we have to find the other way. For the chosen x, we have to find the corresponding reciprocal y value, because that's how function is defined. And then just divide the difference, delta y over delta x, and get the slope. And we may figure out -0.2, -0.238, -0.2487. We may guess -0.25. But let me put these values, okay? I will copy these values. Let's get back to the table. Okay, that's me now how you can get the stuff a little bit more like organized. Of course, that graph that I just did, yeah, we have to understand what we're doing. The green line, one more time, is a tangent, okay? This is tangent, and we're looking for that slope, tangent line. And the blue line is a secant line. And the secant line is getting closer and closer. Of course, I didn't move the line, but I moved the points closer and closer. Okay, let's put these values. First of all, we will need reciprocals. We will need the corresponding y values. For 2.5 was 0.4, 0.4762, and so on. I have the other values. And we did this one. Okay, let's put this one. 4. I think was 4975. I have the other one too in a minute. Okay, now we did calculate the slope. This slope, I just substitute that x value and that y value respectively here. And we will get delta y over delta x. Okay, and the slope was, where is the slope? Negative 0.2, negative 0.238, negative 0.2487. This was actually 0. Okay. Also, what we will also need to work on the y-intercept. Okay, but the y-intercept, how we can get, since we have the slope, we may use the line, I can maybe write here, just this one, mx plus b. We can still use the point slope form, and we will get the b value, the y-intercept, right away. But when we think about the slope intercept, and let's, for instance, think, because we know the point is 2, 1/2. I mean, if y is 1/2, yeah. Oh, actually, no, because this, I mean, we will get, yes, we don't know the slope. In general, let's solve this equation for b. Y minus mx, that's what I wanted to say. Yeah? B will be basically y value minus slope times x value. Right? That's mean y value minus slope times x. Okay. And then if you will get this, b value for the first secant line is 0.9. For the second one that we calculate, 0.9762. And one more, 0.9975. Okay, that's we may possibly estimate. However, if we substitute, if we know the slope, of course, and if we substitute for x2 for y 1/2, then we can also calculate, but we need a slope. Okay, that's what we're doing. We're guessing. Okay, we're guessing. Let's actually look all of the values, and then we will try to guess that question mark. We don't really need this. Yeah? We don't really need this equations of the secant. Don't worry to put, because you have to put the slope. I can put the first one, but we don't really need this. Right? And the slope is 0.2x plus 0.9. But we don't have to copy. What we're looking for this equation. Okay, and let's see all of the values. I will change the slide. Okay, that's the same values that I typed and that I write down, and then it's a little bit more. That means let's see, slope, one more time, negative 0.2, negative 0.38, negative 0.248, negative 0.249. Yeah, we can see it looks like 25, negative 0.25, and the same this one. That's the slope of the secant line between 1.5 and 2. That's the slope, 26, 25, 25, 0. Definitely we can say negative a quarter. And that's I would say this is the good estimation. It's definitely. And then y-intercept is definitely approaching 1. Right? It means the tangent line is negative 25x, that's the slope, negative 0.25x plus 1. Okay, see, this is the tangent line. That's how we estimate. That means it's a little bit time consuming, but the most important thing in this case is to know the method, to understand the concept. I mean, the slope of the tangent line, it's theoretically never a tangent. It's always the secant on the teeny tiny interval. Yeah, that changes the delta x, it's extremely small, and respectively the delta y will be small in that range. Okay, thank you very much. I said that I will also talk about different functions, but let's check my next video, okay, about the, I believe it's 9 graphs, like a fundamental, like the graphs that we have to know them in calculus because they will help us a lot, yeah, if we know the shape. Of course, one of them is that function, 1 over x. Okay, but I just wanted to get the tangent line in this video. Enjoy, and you can do it again. You do have more examples, yeah, in the presentation, lecture presentation. Okay, thank you.